Okay, so we have a request here, guys, for number 3 off the worksheet there. Okay, so we have an object that's thrown horizontally at a velocity of 18 meters per second from the top of a cliff. Right? If the object hit the ground 100 meters from the base of the cliff, how high is the cliff? Okay, so vertically speaking, if it's thrown horizontally, we know VI is 0 meters per second. Okay, we know the acceleration is 9.81 meters per second squared, and we're looking for the vertical displacement, because that's the height of the cliff. Okay, from a horizontal perspective, okay, we know that it is moving at 18 meters per second, and that it's going to travel 100 meters. All right, what can I find right now that will help me get vertical D? Time, yeah, okay. So we've got V equals D over T here, so we're going to go T equals D over V, okay? And so that's going to be 100 over 18. That will give us our time. Okay, so our time is 5.5 repeating seconds. We can bring that over because it's the one thing that applies to both sides. Okay, and now we can calculate D. The formula we're going to need is this one. D equals VI times T plus 1/2 AT squared. We don't even have to manipulate it, and we can eliminate that part of it because VI is 0. So D will equal 1/2 times 9.81 times 5.5 repeating squared. Okay, and that should give us our 151 meters. Okay, yeah. Any other requests there, guys? How many people are on to the angled ones? Okay, good. Okay, so for question number 5, we have another object thrown horizontally off the top of a cliff. Okay, so here's our cliff, and it's thrown at a velocity of 20 meters per second. Okay. The object takes 4.20 seconds to hit the ground. So they gave us time, which is the thing we usually have to find. All right, so we know that that actually applies to both the vertical and the horizontal components of this projectile's motion. So that's kind of a big one. Okay. And sorry, we also know horizontally that V equals 20 meters per second. Okay. If the object, takes 4.2, how far from the base of the cliff did the object hit the ground? So this one's a trick. It sounds hard because the wording is tricky. But all I'm looking for is the horizontal distance. And I have the horizontal velocity and the time. Okay, so I can actually just use those to calculate D. D equals V times T. 20 times 4.2 is 84. Yeah, it seems tricky because it seems like, oh, it can't be that easy, right? And then it ends up being that easy. Okay. So yeah, once in a while, you'll get one that's just worded strangely, and you just got to make sure you go through and know what your givens are and how you can use them. Any other ones? 11, yep. All right, so we have this object thrown from the ground into the air at a 30-degree angle. Okay, the object reaches a maximum height of 5.75 meters. Okay, what else do I know at this 5.75 meters? VF, yeah. I know that at the maximum height, the vertical velocity is 0 meters per second, and that's the key to answering this question, is that extra little piece of information it doesn't tell you. Okay, so it's at its maximum height. We know that VF equals 0. All right, so VF equals 0 meters per second. Okay, we know that the distance, or the displacement, sorry, is 5.75 meters, and we know that the acceleration is negative 9.81 meters per second squared. Okay, so we're looking for the velocity it was thrown at. So we're looking for this. with this information here, can I calculate VI? Yes, I can. Okay, so this is a question that actually doesn't have a lot of math in it, but really tests your understanding of the principles behind angled projectiles. Understanding VF is 0 at the maximum height, okay? That VI is the opposite side of your projected velocities triangle, things like that. If you don't remember those things, then it's impossible to do this question. All right, so I'm looking for VI. I have VF, D, and A, so I would say this is my best bet on that. Okay, that'll get me VI with the information that I have. So manipulated for VI, okay, I'm going to have the square root of VF squared minus 2AD, right? I'm just going to subtract 2AD over to this side and then square root everything. All right, so that's going to mean the square root, I don't know why I'm writing on an angle here. Okay, so we got 0 squared minus 2 times negative 9.81 times 5.75. The signage is important because you have this 0 squared minus. If you don't do that, then your calculator will have a conniption fit because it says you're trying to do something impossible, take the square root of a negative number. Okay? So when we do this, that will get us VI. Okay, so we got the square root of 0 minus 2 times negative 9.81 times 5.75. All right, so we're getting that the initial vertical velocity is 10.62 meters per second. All right, now that I have that, I can go back to my diagram and know that this side here is 10.62 meters per second. Now that I have the opposite side and the angle in the triangle, I can solve for the hypotenuse using trig. Okay, so I'll have the sine of 30 degrees, okay, equals the opposite side, which is what I know, 10.62, over the hypotenuse. So if I want to get the hypotenuse, okay, I am simply going to take the opposite side and divide by the sine of 30 degrees. So basically, I take the 10.62 and divide by the sine of 30, which is 0.5, okay, and that will give me 21.2 meters per second. Okay, so, you know, really only 2 calculations in that question. Okay, so not as much as if I'd asked you to calculate the horizontal distance and then the maximum height like I usually would. Okay, but this one really tests your understanding as opposed to your math. Any others? Okay, keep working then. You're doing good.